Okay, so we're going on to the next video. It's a whole series of videos that are together. This is part 284C3m1b7a5, line 22f1fa19c3m1b7a5, Electron-Hole Recollisions Harmonics 5G Wow Seti. This is keyword research to be filmed, okay, and it's probably going to have some PDFs in it as well. So there's the alien radio signal. November 23rd, I was working on a Google keyword from a previous video of line 22f1fa19c3m1b7a4, laser ADLIS Terahertz pulses, Lin B03 Microfluidics 5G Wow Seti, and today's November 25th, 2012. So the keyword is electron-hole recollisions research. So I'm going to quote from a blog. Nature from March 2012, so it's pretty new. Experimental observation of electron-hole recollisions. There's our people that worked on it. They're from California, USA. An intense laser field can remove an electron from an atom or molecule and pull the electron into a large amplitude oscillation in which it repeatedly collides with the charged core it left behind. Such recollisions result in the emission of very energetic photons by means of high-order harmonic generation, which has been observed in atomic and molecular gases as well as in bulk crystal. An exciton is an atom-like excitation of a solid in which an electron that is excited from the valence band is bound by the column interaction to the hole it left behind. It has been predicted that recollisions between electrons and holes in excitons will result in a new phenomenon, high-order sideband generation. In this process, excitons are created by a weak near-infrared laser of frequency. An intense laser field at a much lower frequency then removes the electron from the exciton and causes it to collide with the resulting hole. New emission is predicted to occur as sidebands of frequency FNIR plus 2NF THZ, where n is an integer that can be much greater than 1. Here, we report the observation of high-order sideband generation in semiconductor quantum wells. Sidebands are observed up to 18 order. There's the calculations there. The intensity of the high-order sidebands decays only weakly with increasing sideband order, confirming the non-perturbative nature of the effect. Sidebands are strongest for linearly polarized terahertz radiation and vanish when the terahertz radiation is circularly polarized. Beyond their fundamental scientific significance, our results suggest a new mechanism for the ultra-fast modulation of light, which has potential applications in terabit rate optical communications. Okay? And that's from www.ncbi.nlm.nih.gov. So the keywords to Google are high-order harmonic generation in the next video. Okay, so my thoughts on November 24th. I'm looking at the keywords in the data from the terahertz collisions. Now, the WOW alien radio signal has given us some ideas about missing bosons from the standard model. The building blocks of the universe and dark matter can probably be found using this new formula I've come up with. See the videos from lines 17 to 22 for the formulas. So the formula keywords from data are intense, laser field, remove, electron, atom, molecule, pole, electron, large amplitude oscillation, repeatedly collides, charged core left behind. Recollisions, emission, energetic photons. You're going to create a Higgs field with this method and see what it leaves behind. High-order harmonic generation, atomic molecular gases, bulk crystal, mixtures of fuel and power for the core of the UFO spaceship formulas in the WOW videos, again from line 17 to 22, okay? There's lines 1 to 16 as well. Those are mostly components for the actual UFO itself, so I think you have to work on the fuel stuff first and then work on the rest of it later, because you want to be able to create this fuel that regenerates itself, right? So you can travel far distances. So exciton, atom, solid, electron, valence band, bound column, interaction hole left behind. Recollisions, electrons, holes, excitons equals New phenomena. High order sideband generation. Excitons created. Weak near infrared laser frequency FNIR. Intense laser Higgs field. Lower frequency plus FTHZ plus THZ radiation waves. Removes electron exciton recollide. Neutrinos. Leptons spin. I added some stuff in there. Leptons spin resulting hole equals dark matter plus new boson particles. That's from the formulas. Those formulas have already been done. They're already filmed, so you can look for them. Just go into the ADLIS YouTube channel and just type in dark matter. It should pop it up. If not, when I do the cross-referencing, I'll have it there for you. New emission predicted sidebands of frequency FNIR 2NF THC integer greater than 1. Observation high order sideband generation. Semiconductor quantum wells. Sidebands observed. That calculation there. Intensity high order sidebands decays weakly, so we can mix it with bosons. Neutrinos increasing sideband order, confirming non-perturbative nature of the effect. Sidebands plus strongest plus linearly polarized terahertz radiation vanish, becomes 0 plus 0 terahertz radiation. Circularly polarized tevatron, so we add the tevatron, the speed, high temperature, and collisions. Then we create a new mechanism that's ultra fast modulation of light. We find the potential. Might be nice if I could actually potential type properly. Yeah. Applications, terabit rate optical communications. I actually do proofread this stuff, but I don't catch everything because I'm so tired from doing it. There's so much to do. Google keywords in the next video. So the next video is going to be covering, actually it's more than one video if you want to know the truth. I'm still researching all these. Large amplitude oscillation, valence band, high order sideband generation, weak near infrared laser frequency, semiconductor quantum wells, and side order. Non-perturbative nature of the effect, modulation of light, and terabit rate optical communications. This is the one I'm really interested in because we're building a device that can go into deep space, and we're probably going to be using this kind of technology. Okay, so thanks for watching.